हरि करना।
Now let's look into the one more distribution which is related to the Poisson distribution parameter, that's a lambda. So which is exponential distribution. So exponential distribution is a continuous probability distribution that describes the time between independent events occurring at a constant rate. So that's what it's a widely used in reliability engineering, queuing theory, and other fields where it is necessary to model time to failure or waiting time. So that's what is your uh, exponential distribution. There is a clear-cut difference between the exponential distribution and then the distribution is one looks into the number of events that are happening in a particular interval. Other one describes the time between independent events occurring at a constant rate. I hope you are getting my point. So using the same parameter, the lambda that we used in the Poisson distribution, we can also model the distribution of the time distribution here. There, the distribution of the number of events that are occurring for a particular interval, but here we are distributing the time between the events. So time between visits to a website, example, the time between visits to a website, there visits to a website in between this interval, but here time time between visits to a website or between cars arriving at a toll plaza. So it's also used in engineering to model time to failure and in process management to model, for example, the time required for service call. So that's what is an exponential distribution. There is a slight difference, but that makes a huge difference when it comes to the application in engineering. So again, I'm repeating, the exponential distribution is a continuous probability distribution that describes the time between independent events occurring at a constant rate. The time between independent events occurring at a constant rate. So it's widely used in reliability engineering, queuing theory, and other fields where it is necessary to model time to failure or waiting times. So we have the probability density function as probability density function PDF of the exponential distribution is given by this. So lambda multiplied by e power minus lambda into x if x is greater than or equals to 0. If x is less than 0, then obviously it's 0. So where lambda is the rate parameter. Then on other side, we also have the cumulative distribution function. This is called CDF of the exponential distribution, which is given by the f of x colon lambda is equals to 1 minus exponential of minus lambda x for if x greater than or equals to 0. So here the mean and the variance of the exponential distribution are both 1 by lambda. So the exponential distribution is widely used in data science, particularly in survival analysis and reliability engineering. So it can be used to model the time between events such as machine failures, customer arrivals, or product defects. So one common application of the exponential distribution in data science is in the analysis of customer wait times in call centers or service centers. By fitting an exponential distribution to the observed wait time data, we can estimate the average waiting time and predict the probability of a customer waiting more than a certain amount of time. So another application of exponential distribution is in the analysis of failure times of mechanical or electronic components. mechanical or electronic components. By modeling the failure times as an exponential distribution, we can estimate the probability of a failure occurring within a certain time period and plan maintenance schedules accordingly. So overall, the exponential distribution is a powerful tool in data science for modeling time to failure or waiting times in a variety of settings.